Gauss. Today I will be discussing to you the chapter 10, um, con- heat transfer by convection in thermodynamics. Here we have a given problem which is heat is transferred at a rate of zero point 0.1 kilowatts through a glass wool insulation with a density of 100 kilograms per cubic meter of 5 centimeter thickness and 2 meter square area. If the hot surface is at 70 degrees Celsius, determine the temperature of the cooler surface. Here we have the given. First is the density, which is the glass wool insulation. It's at 100 kilogram per cubic meter, and the thickness is 5 centimeter. To convert it to meters, we now have 0.05 meters. And for the area given, we have 2 meters squared. And for the temperature of the hot surface, we have 70 degrees Celsius. And the rate of heat transfer is equal to zero point 0.1 kilowatts. And we have to convert it to watts, and we will now have the value of 100 watts. And from the appendix to table 11, from your property table, we have the thermal conductivity of glass wool, which is at 20 degrees Celsius. And we will have a given value of 0.036 watts per meter Kelvin. Here we have the general formula of the of on how to solve for the heat. Solving for In order for us to solve for the temperature of the cooler surface, we have to rearrange the formula. And the arranged form of the formula is will look like this. It will now be the cooler temperature is equal to the surface temperature minus the heat multiplied by the heat loss multiplied by the length over the area multiplied by the K, which is the thermal conductivity. Now plug in the given values, whereas our surface temperature will be 70 degrees Celsius. And for our heat loss will be 100 watts. I mean the rate of heat transfer. Here we have 100 watts multiplied by 0.05 square meters, which is our thickness, and divided by the 2 meter cube, which is our area, multiplied by the thermal conductivity of 0.036 watts per meter Kelvin. And in order for that, using our calculator to solve, we will now be given of a value of the cooler temperature, which is zero point 0.6 degrees Celsius. To sum it all up, first you have to find what are the given, especially the specific ones, and know how to look for the proper values in the property table. Next is to rearrange of what is the given, and to know what will you isolate in order for you to answer correctly. Next is to solve and substitute all the given values and cancel all the units in order for you to find the correct answer of, of the given problem.